Hello, everyone. Welcome to Cassandra.Lunch number 49. We are almost at 1 year. It's probably been about a whole year, but with a couple holidays, but we're almost at number 52. Today's topic is going to be Spark SQL for Cassandra data operations. I'll be the speaker for that, and I'm an engineer here at Anant. Currently, our organizer for this event this meetup is Rahul, but Rahul is looking for co-organizers, and as a co-organizer, you would help spread the word about the event, help find sponsors, and if you're interested in becoming a co-organizer, you can reach out to Rahul at rahul@anant.us. We are a part of Data Community DC. Data Community DC is an inclusive community that no matter your race, creed, gender, identity, we are an inclusive community and everyone is welcome. Data Community DC is made up of a bunch of different organizations. We have things like Data Wranglers DC, which is where we host our data engineers lunches every Monday at noon. Data Viz, and if you're interested in finding out more about Data Community DC, you can visit their website, datacommunitydc.org, and you can find all the different kinds of events that are happening in the DC area. And right now, because everything's virtual, it doesn't necessarily mean you have to attend in person. You might be able to find the right time and the right topic that will be virtual. So what do we cover here in a Cassandra.Lunch? We cover the Cassandra protocol and anything that talks or is compliant with the Cassandra protocol. So that ranges from open source Apache Cassandra to DataStax Enterprise, DataStax Astra, Skilla, Yugabyte, Cosmos DB, Azure Cosmos DB, or Amazon Keyspaces. This is generally a part where if we're in person, we have a couple minutes where we stand up and go talk to someone new that we haven't spoken to before. But since we're virtual, if you're new here, looks like there's a few. I won't pull your teeth to do it, but if you want to say hi, what do you do with Cassandra, or what you could potentially speak about at this event, Apache Cassandra.Lunch. If anyone wants to speak up, they can unmute themselves. Okay, we'll go ahead and move on. So group rules, generally, if you have a question, ask it. This is a community, so if you have any questions or if you have any comments that you would like to add to what potentially the speaker is saying, that you can help and enlighten a point, feel free, but obviously be polite and courteous. Sometimes the presenter may prefer you to add a comment or a question in the chat. But depending on the speaker, they'll give their preferences as they begin their presentation. And again, this is a community, so please feel free to share what you know with us. Here at Anant, we design, build, and manage global data and analytics platforms that focuses on Cassandra, Spark, and Kafka. DataStax is a sponsor and a partner. GW University is also a sponsor, especially for in-person events. They provide us with venue space. We also have some local and institutional sponsors. And this is a quick 15-second announcements. Anyone that has any jobs or is looking for a job, they can drop details in the chat. If anyone has any upcoming meetups or events that they would like to publicize, again, you can drop it in the chat. And in addition to meetups, any hackathons, conferences, or classes. Alrighty. So here at Anant, we are hiring. So if you're looking for full-time or part-time positions, we are looking for data platform operators, engineers, and architects. If you are interested, you can go to careers.anant.us and apply there. All right. And we have some upcoming Cassandra events. Generally, DataStax has weekly workshops, and you can find those on their YouTube channels or their Twitch. And then we have this event every Wednesday at noon Eastern. And then we also, as I mentioned, we have Data Engineers Lunch every Monday at noon Eastern. And we have some upcoming topics for Cassandra.Lunch, such as machine learning with Spark and Cassandra. And then we have a undisclosed topic, but we will update it as it's announced coming up on the 26th. And to find more of our events, you can go to anant.us/events. And you'll be able to find past events as well as live recorded Cassandra lunches on either our events page, or you can find them on YouTube. You can just search Cassandra Lunch on YouTube, and you'll be able to find. We started recording at Cassandra Lunch 10, so everything from Cassandra Lunch 10 to Cassandra Lunch 48 is available on YouTube if you want to go back and watch there. Oh, yep. And also at Anant, we curate Cassandra.Link, or we manage Cassandra.Link, and Cassandra.Link is a hand curated resource where you can find the best Cassandra resources, and you can use it to essentially search, read, watch the best resources on Cassandra. All right, and we will go ahead and get started with today's topic. Can everyone still see my screen?
Yeah, you're good.
Okay. So as mentioned, today's topic is going to be Spark SQL for Cassandra data operations. So if you're not familiar with what Spark is, Spark is a unified analytics engine for large-scale data processing. It achieves high performance for both batch and stream data, and also has a state-of-the-art DAG scheduler, query optimizer, and a physical query engine. We'll be focusing more on the batch side versus streaming, but you can use Spark SQL in stream jobs. But also, Spark has a bunch of different libraries. Ranging from SQL data frames, machine learning. Again, if you're interested in Spark and machine learning in Cassandra, be sure to check out Cassandra Lunch on the 19th. Graph and streaming, and then you can combine these in the same application. And then you can run Spark in a standalone cluster mode or run it on a different container service. We'll be running it on standalone, and then we'll be using it with Cassandra, obviously. So for the demo that we're going to go through, I have the GitHub repo right here. Just give me a second. Sorry. Here it is. I'll send it in the chat. All right. And essentially what we're going to do with this is we're going to do some basic schema commands using Spark SQL. So one thing Spark comes with a couple different shells. They have their Spark shell, which is their native Scala version. They have their PySpark shell. They also have their R shell, and they also have their SQL shell. So we could use the SQL shell. However, the SQL shell provides a bunch, or it outputs a ton of logs that may make it a little bit more difficult to follow along, especially if you're a beginner. Oh, sorry, was there a question? Okay, so going back to what I was saying, um, the output when you make a query using the SQL shell, um, it's a little bit more involved in terms of uh, as compared to just running a Spark SQL query through the Spark shell. And so just for brevity and clarity, we're just going to be using the Spark shell and using the Spark.SQL method. So what we're going to cover is basic schema commands. So we'll show you how to create, alter, and drop tables. There are some limitations for Spark SQL. Um, Rahul, if you're on, you can correct me, but some some limitations include truncating, deleting, and updating. And So during our basic Cassandra data operations, we'll mainly show you how you can read and write using Cassandra data operations, using Spark SQL. And then we'll have one example that does Cassandra to Cassandra. And then we'll have another example that takes a source file and then writes it into Cassandra using Spark.SQL. But yeah, let's go ahead and get started. So with this repo, I'm going to go ahead and open terminal. I'm just going to move some, working off two screens. So there are some generalized parts of the repo, but most of it you can just copy and paste. But some things where it's you need your Spark master URL, that would be a little bit more personal to you, but it's very simple to get. So we're just going to go ahead and start by cloning down the repo with the README. And then we are going to cd into it. All right. And then we're going to go ahead and start our Cassandra. And what we're going to do in this Docker container is we're going to expose 9042. And then we're also going to mount this specific directory on it. So that way we can use our CQL file to create our tables and also load data from this CSV into one of the tables. All right, so while that's happening, I'm going to go ahead and get Spark started. And then once you start the master, you can just go to localhost 8080. And when you're starting a worker, all you need to do is just do sbin start and then point the master URL. So then if I refresh it's on my second screen, but essentially now my worker is logged to my master. So now we should be able to start CQLSH. When we do this, we're going to go ahead and run the source option or command. That's what we're doing in this setup.cql file is essentially creating two tables and then using CQL copy in 100,000 rows from the CSV from here. And then so if we just do a quick describe tables, describe demo dot. Oh, we also created a key space. Apologies. So we created this first table, which is called previous employees by job title. And within there, we have a job title, which is our partition key, an employee ID, employee name, and then their first day and their last day. An employee ID is also used as a clustering column. But then if we look at demo.days worked by previous employees by job title, we notice that there's a difference, right? So what we're doing here in this first table is we're calculating the number of days worked, and that's going to be put into the second table. So that way we don't have a first day and last day. Instead, we just have their duration in days that they worked. But if I just do a select count on, again, as I mentioned, because we imported in 100,000 rows, we're going to use Spark SQL, and we're going to operate on these 100,000 rows from this table and write them with transformations into this second table. So let's go ahead and get started with the Spark shell. So again, as I mentioned, some of these things are a little bit different. So right here, this would be specific to you, but the rest of it can be used exactly the same. So what we're doing here is we're actually going to use the catalog method that comes with the Spark Cassandra connector. And it just allows you to essentially query your schema in Cassandra. So it uses a threefold structure. So we're setting our schema, like the top level, as Cassandra. And then if we want to query our demo key space, it would be Cassandra.Demo. If we want to query a specific table, it would be Cassandra.Demo.Table, if that makes sense. So what we're going to do here is we're just going to go ahead and start up Spark Shell. And while that happens, we are going to move into the basic schema commands. So again, these are pretty much just taken from the Spark Cassandra connector examples, and you can find those in the README linked. So essentially what we're doing with this first query here is we're saying we can create a table using Spark.SQL. So our SQL query goes within quotation marks, within parentheses. So everything here is just a straight SQL query. So we're saying create table. So again, as I mentioned, our schema, our key space, and then we're naming the table test table. We're giving it a key and a type. So key one is integer, et cetera, et cetera, et cetera. And then using Cassandra, and then we partition it. So we're saying we have a compound partition key or partitions. So we have key one, key two, key three. Those are our partition columns. And then we also have clustering columns, which we also set. Actually, while I do this, let me make this a little bit bigger for you guys to see. All right. And so we're also setting clustering columns. So you could use something like table properties. And then we can also set options like compaction, et cetera, et cetera. And more on that, again, can be found in the Spark Cassandra connector docs. But if we then want to look at this table, we can do describe table, Cassandra demo.test table, and we see that this table is created, right? So we see our three keys, our clustering columns, and then we have a partitioning. So we see that the partitions are coming through. So now if we want to alter this table, we can literally just say alter table, point to the specific table, add a column called new column, and its type is integer. So if I rerun this describe, it should be updated. And now we have this, right? Our new column and our integer. So these are just simple methods. Again, this can be more specific to your use case, but this is just how you could potentially use Spark SQL to create and edit your tables. And say if you're done with it and you want to drop it, essentially you could just do Spark SQL, drop table, and it drops the table. So then if I do a show tables from Cassandra.demo, we only have our two tables left that we created previously in our setup.cql file. So now moving back to what we did with setup.cql, we're going to now look at basic Cassandra data operations with Spark SQL, moving data from Cassandra to Cassandra. So what we're going to do with this first example is we're going to go ahead and just pick up the data and make sure we can read it. So we're going to say select all from Cassandra demo previous employees by job title, and then just show it. And we should get back only the top 20 rows, but we're getting back the data we have. And we see we're getting it back in partitions, so we know our SQL copy worked, etc. But again, we have our job title, our employee ID, so partition column, clustering column, and then the rest. So again, from this previous employee's job title, what we will eventually want to do is we'll want to calculate the difference in this between these two values in days per row for 100,000 rows and write that into the second table. So how can we do that with Spark SQL? So essentially what we can do is we can do a insert into. So what we can do here is we can say insert into days worked, which is the second table, and then select job title, employee ID. So select this one, and this one. However, instead of selecting these two, instead give us the date difference between last day and first day, and then give us back the absolute value of that, and then set that as number of days worked, because again, remember, that's what our column here is called, number of days worked. And then from this table. So essentially what we've done here is we've calculated the absolute value difference in days between these two, and we inserted that into the new table. So then if we go into CQLSH and we just say select all from, let's do a count first, from demo.days worked, we should get back 100,000. And we do. So now if we want to make this a little bit more specific, we do select count from, nope, we don't want count. We'll do select all from demo.previous. So this is the original table where job title equals, let's do dentist. So I'm just going to close this for now, and then we'll do the same exact thing, but instead of the first table, we'll query the second table. And so if we look at a nice whole round number, okay, 59 Eden Uden, so that's about 2 months, right? So ideally, if we look for Eden Uden in the first table, if we look for Eden Uden in the first table, we should see the first day and last day only differ by 2 months. So if we look up here, here it is. And if we look at the first day and last day, so this is January 9th, 2000, and then March 9th, 2000. So it's give or take, depending on the timestamp, 59, 60 days. So we know that we were able to use Spark SQL, pick up data from one table, operate on it for 100,000 rows, and insert it into a new table in less than like 2 to 3 seconds. So that just shows you the power of Spark and then Spark.SQL. So now if we want to do something like a join, which Spark SQL does, but natively Cassandra cannot. So like, sorry, I'm just going to paste this here for now. So what we're doing here is we're going to do a select statement. So this is kind of backwards in terms of what we're doing, but it's just to show you that we can use joins on a NoSQL database like Cassandra. So what we're going to do is here, I'll explain it using this here, because this is long. Essentially, it's just we're going to return this table plus the number of days worked. And so we're going to select from the first table and then do a join on employee ID, and then also pull in the column for number of days worked. So then, and then we also do a where just to filter it. So we're just gonna, instead of getting back 100,000, we're just gonna get back X amount, however many dentists there are. And when I run this, we get back job title, employee name, first day and last day, again, from the first table, but then we ran a join, which also pulled in this column from the second table. So if you just do, okay, 58 is a nice number. So this is 2014, May 3rd, and this is June 30th. So that's about 2 months, almost 2 full months, right? So all of May and then all of June. So those numbers still add up relatively quickly. So we know that, or relatively well. So we know that our joins also worked, and we did this on a NoSQL database like Cassandra using something like Spark.SQL. And essentially, if you look at it, it's pretty much just an SQL statement. It just looks a little bit long is because we're using the catalog method, right? So we're doing Cassandra.demo before every table name. We could go around this by saying literally Spark.SQL and then use Cassandra.demo. And then if we say this, we can essentially just drill down 2 levels. So that way, if we remade this join statement, we could go without the top 2 level hierarchy of the schema. So for now, we are going to kill our Spark shell. and then we are going to truncate out our tables in CQLSH. And now if I just do a select all, it's empty, cool. So we are now going to restart our Spark shell, but because we're doing this from a source file instead of Cassandra to Cassandra, we're doing source file to Cassandra. We are going to need to pass in a file. So the file again is already within the directory when you downloaded it. So let me paste this in. So what we're doing here is, again, we're just adding -- files, and we're pointing to, so in the README, it's going to say path to. So whatever your path is, wherever you downloaded it. But for me, it's just users under my name. So if I run this, it's just going to go ahead and start up Spark shell. And then what we're going to do is we're going to load the CSV, so the 100,000 rows, right? Because before we did it with CQL copy, this time we'll do it within Spark itself. So we're going to load it into a data frame. Oh, that's why. Sorry. Again, like I mentioned, in the README, it says path to. I have mine written out here. Okay. And then what we're going to do is, if we wanted to use Spark SQL, we can create a temp view on this CSV. So we're going to use create or replace a temp view, and we're going to call this source. So now if we wanted to use Spark SQL, we can just do spark.sql and then select XXX from source. So source now acts as quote unquote like something that we can query on top of. So now what we can do is we can rerun pretty much the same insert into, but instead of selecting certain columns, we can just say insert into Cassandra.demo previous employees by job title. Again, instead of using CQL copy to upload 100,000 rows, we can then instead just say select all from source. Because again, we loaded that into this CSV. We called it source, or into this data frame. We called it source, and then we select all using the insert into. So now if we go into CQLSH and we do a select all count from, we should get back 100,000, and we do. So that pretty much wraps up some basic Cassandra data operations you can do with Spark SQL. If you have any questions, you can drop them in the chat and we can cover them. Alrighty, it looks like there's no questions. We will go ahead and wrap up for today. Thank you everyone for joining us here for Cassandra.Lunch. Again, this video is being recorded and will be available on YouTube, youtube.com/AnantCorp, or you can search Google for Cassandra.Lunch and you should be able to find the playlist. If you're interested in becoming a speaker at Cassandra.Lunch or a co-organizer, you can reach out to us either at rahul@anant.us or me, arpan.patel@anant.us, and we can get you scheduled to speak. And since we have about half an hour left, we can open up the floor to community discussion. So this part can be any topics regarding Cassandra that you have any questions for. You can bring it up and see if you can get a response from someone who's here. And Josh, we can wrap it up. Thank you.